Hello, my name is Emory Hill, and I will be presenting my gravitation lab. So to start with our purpose, the purpose of the experiment was to calculate the initial velocity required for a spacecraft to escape the orbit of a planet that is orbiting a black hole, and for it to also escape the gravitational force of the black hole itself. Two models were coded in GlowScript to do this. So to start with some physics principles, we have Newton's first law stating that when forces act on objects, motion does change. And then the second law, F equals ma, also the momentum principle. The kinematic equations, position update formula, velocity update formula are important to track the motion of the objects in the lab. And then the gravitational force formula and the relationship between force and momentum are important for the calculations themselves. The GlowScript coding program was used to create two models. The first model calculates the mass of the black hole, and the second model allows me to test velocities to determine if the ship would escape. On the right there is just a sample of the code used. So for a brief preview of the main results, we have both models here. On the left, you can see that is the model that was used to calculate the mass of the black hole, and on the right, that is the model showing the ship trajectory after it escapes the orbit of the black hole and planet. I'm going to go deeper into this on the next slides. First, I would like to recognize the system, surroundings, and initial conditions. The system in each model is a little bit different, but in the first one, it's the black hole. The system is the star, and the surroundings is the black hole. In the second one, the surroundings are the black hole and the planet, and the system is the ship. On the right there, I do have the masses of everything in the lab listed, along with the position of the planet and shuttle. The trajectory was randomly generated. So to go through the procedure here, the first model was created from starter code. An email address was actually used to generate the random trajectory. Momentum and gravitational force were used in the first model to calculate the mass of the black hole. The mass of the black hole was averaged into one mass and then put into the second model, where distances, forces, and net forces were calculated using gravitational force, and then I can input velocities and test whether they allow the ship to escape the orbit or not. So here's a peek at the coding in the first model. It's color-coded there, and you can look at the descriptions there. But generally, a lot of calculations had to be made for momentum, force, and unit vectors. And then at the bottom, the distance was calculated and then used to calculate the mass of the black hole itself. Here is a peek at the code in the second model, and again, it's similar. A lot of unit vectors had to be calculated. That's the blue, and then the forces in the red, and the yellow is the distances between each object in the lab. In this one, there was a lot of calculating of the forces of each object on each other. And at the bottom, you can see position and velocity update in the gray and the purple. So for the overall results here, I determined generally that the initial velocity required for the ship to escape is around 10,000 meters per second. The number seems large, but again, the mass of the black hole is super large, so there's this extremely powerful gravitational force. So to escape, the ship must have a very high speed. Now, the models look a little bit different. The one on the right is just very zoomed out, and the line you see there is the trajectory of the shuttle after it is leaving the planet and black hole. Again, the initial velocity there, 10,000 meters per second, is just an estimate because I did have to manually test values. So there is a lot of similarities and differences between the first and second model, but generally the main idea is that the first model was used to create the second model, so they aren't really necessarily meant to be compared. They do share a lot of data, but the second model is just fundamentally different from the first. Now, the difference between rate of change of momentum and net force, well, force is just the first derivative of momentum, but rate of change of momentum is the second derivative. For the ship to enter an orbit around the black hole, it has to travel less than 10,000 meters per second, but there's a very small window because of how it could end up crashing into the black hole. There's very little room for error in this experiment because it's entirely computational, but coding mistakes could have occurred. Thank you for watching.